In Activity 11, Precipitation, students observe and define the formation of precipitation. They first discuss the water cycle in nature and relate it to what they have learned about evaporation and condensation. Students then begin to use a rain gauge to measure rainfall during their daily weather observations. You will need the following materials from the kit: Activity Sheet 11, Parts A and B, envelopes from Activity 10, water cycle chart, weather data chart from Activity 10, plastic jar, rain gauge, and a rubber band. You will also need to provide ice cubes, sheet of plastic wrap, and hot tap water. To prepare for the activity, make a copy of Activity Sheet 11, Parts A and B for each student. Put up the water cycle chart where the students can easily see it. Select an outdoor location away from buildings where the rain gauge may be installed. You may want to tape over the inches scale on the gauge since it will not be used. About 15 minutes before beginning the activity, set up the plastic jars in Activity 9 and fill it 1/3 full with hot tap water. Cover the plastic jar with plastic wrap and secure the wrap with a rubber band. Then place about 4 ice cubes on top of the plastic wrap. To begin the activity, invite the students to look out the window to view if there's any precipitation. Explain that precipitation is any form of water that falls from the sky to earth. Ask students, what forms of precipitation have you seen? Encourage them to share their experiences with different forms of precipitation. Examples should include rain, snow, hail, and sleet. Next, ask students, where does precipitation come from? Students should mention clouds in their answers. Show them the plastic jar setup and remind them what it was used for in the previous activity. Then ask students, why do you think the water droplets do not fall to the ground as rain or drizzle? Students may suggest that clouds are very light. Explain that the droplets in a cloud are so small that the rising warm air is strong enough to hold them up. The droplets can only fall as rain once they become large enough and heavy enough that they are too heavy for the rising air to keep up. Ask students, what do you think we might do to make our cloud produce rain? Students may say that the condensed water droplets in the cloud must form larger water droplets. Then ask the students, how can we make the droplets get bigger? Guide students to understand that if you wait long enough, water vapor will condense on the cold plastic wrap, just as, in the earlier experiment, water vapor condensed on the walls of the ice-filled tumbler to form droplets big enough to see clearly. Students should observe condensation forming on the underside of the plastic wrap. As the droplets collect, the droplets get larger until they drip off in large drops. After about 30 minutes, the condensation drops on the underside of the plastic wrap will begin to fall back into the water in the jar. Ask students, what does the condensation that falls from the plastic wrap represent? Some students will realize that the condensation that falls back into the warm water in the jar represents precipitation. Ask students, what needs to happen to the water vapor in the air in order for precipitation to occur? Students should reply that the water vapor must condense into large enough drops. When water vapor in the air becomes cold enough, it condenses into tiny droplets of water. We see these droplets as clouds. If the water drops in clouds get big enough, they fall back to earth as rain. Inform the students that the process of continuous evaporation and condensation of moisture is called the water cycle. Next, draw the students' attention to the water cycle chart and explain the changes that water undergoes through the cycle. Point out that the sun warms water in lakes and other bodies of water. The water then evaporates and enters the air as water vapor. Finally, water vapor cools, condenses, and falls as rain, which collects in lakes and other bodies of water. After reviewing the water cycle chart, ask students, how do you think we might measure precipitation? Accept all reasonable answers. Tell the students that the rain gauge is an instrument used to measure the amount of precipitation. Inform the students that they will be measuring precipitation in millimeters. Millimeters are a metric unit of length equal to 0.1 centimeters or 0.001 meters. Add some water to the rain gauge and show the students. Have several volunteers come and read the level of water in the rain gauge. Ask students, how did you determine the amount of water that is in the rain gauge? They should determine the water level by reading where the water falls on the scale, similar to a thermometer. Make sure that they use the millimeter scale and that they state the units of measurement. Next, give each student a copy of Activity Sheet 11, Part A. Instruct them to complete the exercise and then review their answers. Then, direct the students' attention to the rain gauge. Ask students, what do we need to do to the rain gauge before we install it? Guide students to understand that water must be emptied from the gauge. This step is necessary because each reading should show only the rain that has fallen since the last reading. Students may suggest that they could find the difference between the previous reading and the current reading. Help them realize that this would be inaccurate because of evaporation. Give the students their journal envelopes and a copy of Activity Sheet 11, Part B, and take them outside to install the rain gauge. Then, instruct students to record precipitation data on Activity Sheet 11, Part B. After making their observations, tell students to also add precipitation data to the class weather data chart. Finally, have students observe the rain gauge each morning and afternoon for about a week. Make sure the class records its collective data on the weather data chart daily in addition to on their activity sheets. To conclude the activity, empty the jar, air dry it, and return it to the kit. Leave the water cycle chart up for the remainder of the module. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.